A couple more problems on the last page. Now the hint I'm giving you is draw a diagram first when you have a word problem. A gardener wishes to enclose a rectangular plot of land using a roll of wire netting that is 40 meters long. One side of the plot is to be the wall of the garden. Okay, so let's say you got a wall, and the gardener is going to make a garden or a plot, a section of land using fence. And the total amount of fence is 40 meters. Okay? One side of the fence is the wall, so you only use 40 meters for 3 sides of the wall. How should he bend the wire netting to enclose the maximum area? Okay, we're going to have to make some variables here. Let's call this the width, and this the height. And then let's find the area because it says the maximum area. That's the variable we want to maximize. It depends on W and H, right? Because the area is W and H. Okay? Now, unfortunately, we have the variable we want to maximize, and we have two variables over here. The only way we can figure out what the optimum area is if we eliminate either the W or the H. How do we eliminate the W or the H? Well, look here. We have something that can relate W to H and the length 40 meters. It looks like if we add the two W's and an H, we should get 40 because that's how much fencing we have. So that's the same thing as 2W plus H equals 40. And let's solve for H. Get 40 minus 2W. And then now we can substitute that in here, and we'll get A with only W's. Now we have A just with W's. And now we can graph that. And when we do, that is going to, instead of W, we have to put X, right? 40 minus 2X. I'm going to graph it. And it's going to be a quadratic. And whoop, it's going off the screen. So we can adjust that by changing the window size. So the X max, let's change it to something like 100 so that we can see more. Okay, so we'll do second calc, and we're trying to find the maximum. And so the left bound, let's try to go, oh, there's the cursor, and then we're going to go a little bit to the left of the maximum, we hit enter. We go a little bit to the right of the maximum, we hit enter. And then we guess, and then the answer is going to be 10, 200. Okay, and what was this again? This was W and this was A, right? So how should he bend the wire netting to enclose the maximum area? Well, the W should be 10, and the H should be 20. That would give you an area of 200, which apparently is the maximum possible one. Okay, we'll go to number 5. A long strip of metal 120 centimeters wide is bent to form the base and two sides of a chute. A chute is like a big square tube, or a rectangular tube with a rectangular cross section. Okay. Find the width of the base that makes the area of the cross section a maximum. Okay, and again I'm going to draw a diagram because that helps. Okay, it says a long strip of metal is 120 centimeters wide, is bent to form the base and two sides of a chute with a rectangular cross section. Find the width of the base that makes the area of the cross section a maximum. Okay, so what you have is you got like a piece of sheet metal, it's 120 wide, and we're going to bend it into a U. A chute could be an enclosed rectangle, or it could be an open rectangle like this one. So what they're doing is they're saying, hey, this purple area here, this purple line, this plus this plus this is equal to 120. Okay? I'm going to erase this misleading drawing that makes it look like it's a closed rectangle. Now let's try to write equations for this. So we want to make the cross-section a maximum. The cross-section would be this area here. The cross-section, let's give it as A. So A is equal to, and I'll call this width, and I'll call this height, and I'll call this height. So the area is width, height times width, right? And then I can relate h to w by saying, hey, h plus w is equal to 120, right? Or 2h plus w equals 120. And I want to optimize A. I want to make it maximum possible. So let's get rid of either the h or the w. It's easier to get rid of the w. By subtracting 2h from both sides, we get that. And then we substitute the w in there, and then we get h times 120 minus 2h. And now we have an equation for A just in terms of the h variable. And so now we can put that in the calculator, and we can change the h to an x because there is no x in the calculator. And we'll put 120 minus 2h, or 2x. And then we'll graph it, and we'll get a quadratic. We can't see too much of it. Maybe we should do zoom fit, which is option 0. Oops. Zoom, option 0, and there it is. Okay, and then it says, find the width of the base that makes the area of the cross-section a maximum. So when is the area maximum? It's right there. We'll do second calc, and then, second calc, I say. And we'll try to find the maximum, which is option 4. Oops, wrong place. I did the left bound in the wrong place, so I'm going to go back and start over again. Maximum 4, and then I'm going to do the left bound. We've got to move to the left side of the max, and then we go to the right side of the max. And then we guess. And then the maximum is going to be 30, 1800. Now what is the 30? The 30, remember, is h, and the 1800 is area. So it says find the width of the base that makes the area of the cross-section a maximum. So we know that the maximum cross-section is 1800, and we know that the h of 30 makes it maximum. But what value of w makes it maximum? So we can find that with this equation here. We can put h in for, we can put 30 in for h, and then we get 120 minus 60 equals 60. So the width that makes it maximum is 60. And that is the end of this section.